Okay, question number 21. Here are the first four terms of a quadratic sequence: 11, 26, 45, 68. Work out an expression for the nth term. Well, this is a standard type of question, finding the nth term of a quadratic sequence, and it's going to come out to an squared plus bn plus c. And we've got to find out what a, b and c are. By the way, b or c could be 0. We'll see what happens in the case of this particular question here. So the way to do this is to write out a table. N is 1, 2, 3, 4. That's for the first four terms. And the nth term is 11 and 26 and 45 and 68. Now the really essential thing is that I've left a blank column between 1 and 2, 2 and 3, 3 and 4. That is utterly essential that you do that. Okay, now on to the next row, where we work out what I'm calling D1, the first differences. So 11 to 26 is 15, 26 to 45 is 19, 45 to 68 is 23. Those are the first differences. Now we need the second differences. We need the differences of the differences. 15 to 19 is 4, and 19 to 23 is 4 again. Now we've only got 4 twice there because we've only got 4 terms to start with, but however many of those you've got in D2, 4 and 4, they must all be the same. If they're not all the same, if they are different from each other, either you've made a mistake in your working, or perhaps it wasn't a quadratic sequence to begin with. So you need to check your working and check the question. Are you sure it is a quadratic sequence? Well, this one is, because it says so. Here are the first 4 terms of a quadratic sequence. Right, what do you do with those 4s? You halve them. You always halve that number, that D2 number. So if I halve that, to find A is a half of 4, which is 2. So A is 2, guaranteed. So the sequence, the formula for this sequence begins 2n squared plus bn plus c. And I've got to find out what b and c actually are. But I do know it begins with 2n squared. Okay, so the thing to do then is to work out 2n squared in each case and subtract it from tn. So for instance, on the very first entry, I need to work out 2 times 1 squared, that's 2, and take it away from 11, that's 9. In the second column, I need to work out 2 times 2 squared, well that would be 8, and take that away from 26, that gives me 18, and so on. And it's this residue here, 9, 18, 27, 36, I've got to find a formula for that, and that must be a linear sequence. It goes up or down by the same amount every time. It does, it goes up by 9 every time. So what is the formula for that? Well, it goes up by 9, so you start with 9n, and then there's usually a plus 1 or a minus 1 or something. And the way I tell people to find out whether it's plus 1 or minus 1 or whatever is I say look at the 0th term, the term before the first term. It's going 36, 27, 18, 9 as I read from right to left, and the 0th term will be 0. That's why I've written 9n plus 0 in brackets. Don't write that down for the examiner. They won't like it. That's just 9n. Okay, so the overall formula is that Tn is 2n squared plus 9n. Alright, well I do approve of people checking things. I think you should, because it could save you marks, real significant number of marks in the exam if you have made mistakes. So let's work out T4. T4, look at the formula, it's 2 times 4 squared. 4 squared is 16, times 2 is 32, and it's 9 times 4, which is 36, and when you add those two numbers together you get 68. Brilliant, that's what it's supposed to be. Now if you're feeling very uncertain of yourself, you could check the third and the second and the first term as well. But I think if I were doing this in a pressure situation, then I would check the fourth term, make sure that it works, and then move on to the next question. I'd feel pretty certain I'd got it right. So there we go then. The answer is that the nth term is 2n squared plus 9n. But you do need to show, possibly the table with all those lines in, to show how you got there. Just writing down 2n squared plus 9n, probably doing all the work in your head, that's not good enough. You've got to show the examiner how you got there. It's worth 3 marks and you must show some working. There you go, that's the end of that question.